This is 1.5, domain restrictions. Here is your essential question. Basically, what we're going to be looking at, domain restricted, it means we're going to be graphing partial graphs in a way. Okay, so it's asking, what would the graph of f of x equals x look like? So that's a line, y equals x. It's the most basic line. But what would it look like if we only graphed where x was greater than 0? So we aren't going to graph the whole thing, only where the x values are greater than 0. Okay, so we're going to come in going in with things with closed dots and open dots and stuff like that. So I do want to point out a couple things. If you have either greater than or less than, these are going to be your open dot. Okay, meaning we're including everything up until that specific number. Okay? If you have greater than or equal to or less than or equal to, these are going to be your closed dot. That means we're including everything up until that number and that number because it's the equal to part, right? The equal to part is what makes it included. Okay, so are we including or are we not including? That's important. So when we're doing this, we always look at the boundary point. That boundary point is where we're cutting things off. So graph of f of x is greater than 0, 0, x value of 0 is our boundary point. Now realize, this is greater than, that 0 is not included, but it's where we're stopping. So we're going to have an open dot wherever that is. So in this case, when we plug in 0, we get out 0. Right? Don't forget that when you see those parentheses like that with the number inside, it's telling you plug in that number. So when we plug in 0, we get out 0. Okay, so that means my boundary point is 0, 0, which happens to also be our key point, which is kind of nice. But it's an open dot. So when you put it on the graph, it's kind of hard to see on this. But notice I'm not shading it in, it's an open dot. Okay, I also like to actually put in a little thing, make it really light, because it's definitely not a graph, it's not an asymptote, it's just a little line to remember that's our boundary. Do not go past that, right? So then we have to think, is it going to the right or going to the left? So it's where my x values are greater than 0. So all these over here are negative, those are less than 0. So all these over here are positive, these numbers, those are greater than 0. So notice the arrow, if you think about this little sign as an arrow, it's pointing to the right. All the numbers to the right, that's greater than. Okay, so we're going to follow our slope. Our slope is 1, so up 1 over 1, up 1 over 1, and so on. And we don't stop, right? It's going to keep going. So I'm actually going to draw an arrow because it's going to keep going that way. On the left side, though, I am not drawing anything. I'm stuck at 0. That's my boundary because everything to the left of that point does not fit my boundary. Okay. Then it says, what is the domain and range? So this is interesting. It's a little different, right? We don't have anything to the left. So the leftmost point is 0, not included. And then it goes on to infinity, left to right. Now I'm going down to up. So the furthest down I go is actually also 0, not included, because it's an open dot. And then it goes on up forever, so infinity. Okay. So let's try a little bit harder of one. My boundary is -3 now. No. So I want x to be greater than -3. So I'm going to plug that in. It's not quite going to fit on this axis, just to warn you, but it's close. So I plug in -3, -3 squared. It's -3 times -3, so that makes positive. Negative times a negative makes positive 9. So my boundary point is -3, 9. Okay, so at -3, I'm going to draw a little dotted line. Remind myself I can't go past that. This time it's an open dot again at -3, 9. So 1, 2, 6, 7, 8, 9. Okay, so it's just off the graph, but that is actually the correct spot. Okay. Now I think about how I would normally graph a quadratic function. So I think of my key point, so there's no shift, so that's 0, 0. Now I have to think, is this greater than my boundary? It is, right? It's to the right of my boundary, so that's good. Okay, if it's not, we gotta be careful. We gotta think about where that, how we can't graph that point because it's not within our boundary. This time it is, so we're good. And then we just follow our 1a, 3a, 5a. So our a is 1, so I'm going to go over 1, up 1, and mirror it from that new point, over 1, up 3, and then I can mirror it. And that's enough. I can just kind of sketch in my u. Okay, notice I have the arrow to the right, not to the left. I'm stopping there because that's my boundary. So my domain, how far left? I'm going from -3, not including, to how far right? Infinity. It's going right forever. Range, I'm actually going down to 0, including it. Oops. All right, because it is a closed dot at 0. It is included. And then I'm going up forever, so infinity. Okay, a lot of people say, well, what about that dot right there? It's a hole. But because it is included, right, this arrow means going forever, so it's included there, so we're good. All right. So let's try other functions. So now we're going to try an absolute value. Okay, so first we look at our boundary. Our boundary is that it cannot equal -2. Okay, so if I plugged in -2, remember absolute value makes everything positive. So when I plug in -2, I get out +2. So -2, 2. Okay, this one is a little tricky for people. So -2, 2. I'm going to put in a hole because I cannot equal it, right? So I have to have a hole there. But I don't really know if I want to draw a boundary here because it's not telling me I have to be greater than or I have to be less than. It's saying I just can't equal that. So everything else is good. So how would I normally graph this? Key point 0, 0. Basically a slope of 1. And I draw in my v. It's positive, so it's going up. I just don't fill in the hole because that is where I cannot equal. Everything else is included. Okay, so my domain is a little funny. I'm going from -infinity to my hole, which is -2. Then I'm picking right back up at that hole, or just after that hole, to infinity, right? So that's how we'd write out that with a hole at -2. I write it out like that. And then a lot of people get stuck on the range. It's 0 included, because I go down to this point, that's furthest down, and I'm going up forever. If I look at the right side, I go up forever. Yes, there is a hole here, but it is included somewhere else, so we're good. Infinity. Okay. Now we have a different kind of restriction. Now we're restricting it twice, both sides. So we have a 0 and a 6. We have 2 boundary points. So when I plug in 0, okay, a lot of people get confused. Where would I plug in 0? Well, you plug in 0 for x. There is no x. So no matter what we plug in, we actually get out 3. So I have 2 boundary points, 0, 3, and 6, 3. Okay? So we gotta look at the function here, or the inequality here. I'm not including 0, I am including 6. So at 0, 3, I have a hole. At 6, 3, I have a closed dot. Okay, then we have to think, well, this is y equals 3, so that's just a horizontal line. I don't need extra points. Just draw a horizontal line. Okay. So my domain, how far left to how far right? I'm going from 0, not including it, to 6, including it. So parenthesis on the 0, bracket on the 6. Oh, I guess we've been doing this, so I should do this. This would be my boundaries. I have 2 boundaries now. It's just however many boundaries you have. Think about that. So it can't be, it has to be between those 2, basically, because that's what the inequality is telling me to do. Now the range throws people off, but it's actually quite easy. The range is 3. It's the only number, so that's my range, 3. If it's not, if the y value is not a 3, it's not on this graph. Okay, and then we get into a little more complicated of things. So we have a quadratic with a left 2, up 2 shift. It's a negative, so it's going down, and I am restricting it to -2. So if I plug in negative 2, I would get 0 plus 2, which is 2. Right, negative 2 plus 2 makes 0. 0 squared is 0. 0 times anything is 0 plus 2. So that's where that comes from. And so my boundary point is negative 2, 2. Okay. It is included, right? It has the equals 2. So I'm going to actually put a point. Negative 2, 2. Okay. And that's my boundary. So I'll draw in a little boundary line. Now I got to think. This is a left 2, up 2. So from 0, 0, left 2, up 2. Ah, that's actually my key point. Okay. So it's a negative 1, so 1a, 3a, 5a. So I'd be going right 1, down 1, right 1, down 3, and right 1, down 5 if I want to keep going. We would normally mirror it, but I have my boundary. It says greater than. I have to be to the right of that line. If it's less than, I'd be on the left side, right? Greater than is on the right side. So I don't mirror it in this case. I just basically have a half a parabola because it's restricted. Okay, so how far left? I go from negative 2 to infinity because I'm going forever to the right. My range, how far down do I go? I go down forever, but I only go up to positive 2 including. Okay, so quadratics are actually some of the hardest things for most people, so let's do another one. So right here, I'm restricting, so I'm going to plug in negative 3, so I get negative 2 squared, which is 4. 4 minus 3 is 1. And I plug in 1, I get 2 squared, which is also 4, minus 3, which is 1. So I have my 2 points, negative 3, 1, and 1, 1. Okay. I am including the one, or sorry, not including the one at negative 3. I am including the one at 1. So negative 3, 1, that's a hole. 1, 1, that's a closed dot. And I'm going to draw my boundary lines. I like to draw the boundary lines. Remember, you can draw them in really light, but they're there to remember. This is telling me I have to be between those 2 points. Okay, so now I would actually graph it like normal. So I got to think, how would I graph this? It's a left 1, down 3 shift. Right there, which is nice. That is in between my boundaries, so I can put that point. And then I'd use 1a, 3a, 5a, so over 1, up 1, since my a is 1. Over 1, up 3 is actually the next point, so I'm going to draw in the u. When you draw in this u, stop. No arrows, don't continue past. That is the boundary, that's the wall, right? You can't go past that, because that's what we are restricted to. Okay, so my domain, going from negative 3 to 1, including the 1, not including the negative 3. My range, it's coincidence, but it happens to be, my lowest point is negative 3, but notice it is included, it's a solid dot here. My highest point is positive 1. I have 1 included, 1 not included. As long as 1 is included, it is included in the graph. So it's bracket for both in that case. Okay. Then we get to examples 4 and 5. These should have, by the way, arrows on them. I used Desmos, and Desmos didn't have arrows when I made these. Okay, so it says write the equation for the graph shown. So now we have to write the equation. So let's look at some points. We're given this point as 2, 1. That's my vertex, or key point. My key point is 2, 1. I know it's a quadratic, it's a U shape, so it's going to be some sort of squared thing. And then I have my extra point, which is 3, 2, which we're going to need to find the a value. So I'm going to start off with y equals, then I want to shift. So I'm going to have a right 2, up 1 shift. So a, I don't know that one yet, x minus 2 squared plus 1. Okay, you need to know how to write out your normal function. I'll write the little thing if you've forgotten, y equals ax minus h squared plus k. So h and k are my left-right shifts, so minus 2 plus 1 makes it this. Now I need to plug in my extra point, 3 comma 2. So I'm calling in 2 for y, 3 for x. Okay, so I just solve. So I get 1 squared plus 1. So I get 2 equals a plus 1. 1 squared is 1. A times 1 is a. Okay, so I just subtract. I get 1 equals a. So a equals 1. Alright, so I got my equation. F of x equals 1, or you don't have to write it if you don't want. X minus 2 squared plus 1. If, right, we have the domain restriction. So now we have to restrict it. So I want my x, we always restrict the x, so x is, it's not included, so it's either going to be greater than or less than, it's to the right. So if x is greater than positive 1. Right, because that's my restriction. If you want to draw the little boundary line, because that's what you're used to seeing, you can. So I'm going to the right, that's greater than, less than is left. And then it's not included, so it's no equals 2. And that x value is 1, so x is greater than 1. Okay, last thing, so we have an absolute value now. So we have our vertex is negative 2, negative 3. I know there's going to be an absolute value in there. So an absolute value is y equals a, x minus h plus k. And so y equals a, x plus 2 minus 3. We're left 2, down 3. Alright. Now I use my plug in my point to get to my thing, or you can actually count slope if you notice how to do that. But if you don't, you can just plug in. So negative 1 for y, 2 for x. So 2 plus 2 is 4. Don't forget, absolute value just makes everything positive. Oops. So 4 is positive. Okay. So then I add 3 to both sides, move that over. Then I divide by 4 on both sides, and simplify is 1/2. A equals 1/2, which, by the way, if you counted up 1 over 2, up 1 over 2, you would have gotten the same thing. So 1/2 x plus 2 minus 3. If, okay, now we gotta look at our boundaries. So our boundary is right here. It is included this time, so x is greater than or equal to, because it's to the right, and included, so it's greater than or equal to. Greater than to the right, equal to makes it included. And then we're looking at the x value, so 1, 2, 3, 4, and negative 4. And that's my answer. That's the equation. Okay. So make sure you write your 3-sentence summary answering that essential question.